Good evening, everyone. Hope you're all doing well. Okay.
Hey, Professor, did we all have to individually submit the team charter assignment, or was just
one person per team?
All right. Thank you.
Sure. Okay, so it's 28 of us. Let's give everyone a minute or two to join. And while we are waiting, if there are any questions for me, I would be able to answer them. No questions? Okay, fantastic. So a little feedback about the class, general feedback. What do you think?
It's super interesting and super complicated.
Okay, I'm glad to hear that it's interesting.
You want to shut the door?
I beg your pardon?
The dog is on coming.
Okay, so when you say complicated, you mean that time is not enough for assignments?
Sorry. Let me rephrase.
Okay.
I should say the subject matter is very complex. Like
Okay.
as we go through it, just gets you thinking of how many various factors go into supplying anything anywhere.
Correct.
Yeah.
Correct. Okay, thank you. Thank you for this observation. And please feel free to reach out to me. I received a few emails from you right before the class. I will get back to you either tonight or tomorrow. If you need any basically accommodation, extension, and if you need more time to work on something, if you need more explanation on something, send me an email. We can work on it offline. I might be able to record a video and send it to you. We might be able to have a office hours and things of that nature. So if there are no questions, let's go ahead and get started with assignments of chapter 9. So tonight we will go over the assignments of chapter 9, and at the end we will discuss the case study, which is the Bank USA case. So let me go ahead and start sharing my screen with you. Okay, so first part of your assignment is a few exploring operations activities on the moving average, exponential smoothing, and regression analysis, and comparing basically the different methods in terms of MSE, and also comparing moving average and exponential smoothing forecasts. So let's go ahead and work on these. These are basically the assignments of those interactive graphs that we saw in class when we worked on them in class together. Give me 1 second. Let's see. Need to rearrange this page so I can see you all. And okay, this is good. And I see that I have, okay. Brian is in the waiting room. Let me open the chat as well. So if you want to say something, you can always use the chat function. Fantastic. Okay, so let's start with the first assignment, exploring operations moving average forecast. Okay, so here we have it's pretty close to what we saw, as I mentioned in class. This is the same basically graph, and it basically goes over naive forecast, which is a 1 month moving average, and then 2 month moving average, 3 month moving average, and 4 month moving average. It calculates MSE for you and shows that as you move along and increase the number for the period set to consider for calculating the moving average, the level of smoothness of your predictions would get increased. So based on this graph, we have to answer a few questions. First question says, for the milk sales data shown, which of the following forecasting techniques result in the smallest mean squared error? So basically what you need to do is just click on these different methods. You see that for naive forecast, you have 2,462. Here you have 1614. 1475 and 1538. You see that the sweet spot here is 3 months moving average, which has the lowest mean squared error. Question number 2, the milk sale volume decreased significantly in month 11. For which forecasting method does the estimate for month 12 change the most when compared to the estimate for month 11? Meaning, which is the most responsive to changes in the data? Okay, so even without looking at this graph, you should be able to tell me which one is the most responsive. Okay, again, as you remember from our discussion, as you go from naive forecast towards your 2-month moving average, 3-month moving average, and 4-month moving average, the level of smoothness of your graph increases. That means that the level of responsiveness decreases. So that means that the most responsive is the naive forecast. And as you can see here, this is also shows that, okay, this is exactly shows how from actual value of the month 12, is it weeks or 12 months? Yeah, month 11 to month 12, you see that this is the highest fluctuation and most responsive. And so this is going to be the naive forecast. And then the milk sales volume decreases significantly in month 5. For which forecasting method does the estimate for month 6 actually increases slightly? Okay, so as you can see here in month 5, that which we have here, the sales basically decreases. Okay, but we want to see which one of these basically increase, which one of the forecasts basically increase in month 6. Okay, so you see that for naive forecast we see a decrease. For 2-month moving average, you see a decrease. For 3-month moving average, you see a decrease. And for 4-month moving average, you actually see an increase between months 5 and 6. So which is the opposite of the actual direction of these 2 months. So that would be the answer here for question number 3. And then for question number 4, for which method is the first forecast value available the soonest? So this is again pretty straightforward, and we have only 1 month, 1 period moving average, which is the naive forecast. Our data is available as soon as we have the data for the first month, and we can start forecasting for the second month. So this is our first part of the assignment. If you don't have any questions, let's go to second part, which is the exponential smoothing forecast. So here, again, we have the exponential smoothing graph, and these are the values of alpha, which we can change. We can start from 0 all the way to 1. Again, you remember for 1, the value of alpha equals to 1 would be a naive forecast. Basically, it's going to be ft plus alpha times at minus ft. And then if alpha is 1, it's going to be ft plus at minus ft, which is basically ft plus 1 is exactly equal to at, meaning that the forecast for the next period is going to be the actual value of this period. Okay. So, and then as you see, as we decrease the level of alpha, means that we are putting basically, for example, 20% emphasis on the error and 80% emphasis and 80% weight on the previous period. Okay, so that basically smooths the process. So now let's go ahead and, based on this, take a quick look at the questions. For what values of the smoothing constant alpha does the exponential smoothing method looks like a naive forecast method? So we just saw that it's a value of 1. And then question number 2, for what values of a smoothing constant results in the smallest mean squared error? So we can just check these 4 or 5 values that we have. We have value of 0. We see that it is 1636. We have value of 0.18, which gives us 1282. We have value of 36, which gives us 1390. I have value of 0.5, which gives us 1543. And finally, we have value of 1, which gives us 2462.55. Again, as you can see, 0.18 was the lowest value, to 1282.73 is the amount of MSE. So that is going to be the answer here. And then part 3, which of the following is least accurate? So let's take a look at these one by one. The smaller the value of a smoothing forecast, smoothing constant, the smoother the forecast series. So that's correct. As we remember, when we decrease this value of alpha, this will be smoother. Our forecast would be much smoother. So this is correct, and it's not least. So this is correct, and it's not least accurate. So that's not the answer. B says when the smoothing constant is 0, the mean squared error is minimized. So as you remember from the previous question, the MSE doesn't have anything to do. It doesn't have a direct relationship with alpha. And it basically goes up and it comes down. So that is the answer. This is not accurate. But now let's take a look at C and D and see why they are correct. The larger the smoothing constant, the less weight the forecast places on the prior forecast values. This is again correct. So when we have a value of, for example, pretty close to 1, we are putting a very great emphasis on the very on the current period, basically, and we are putting, for example, we are putting, if this is 90%, we are putting 90% weight on the current period, and we are putting 10% weight on the forecast of the current period, which is carrying all the previous months or periods with itself. So we are putting only 10% weight on the whatever is not included in this period. Okay, so that is true as well. And the smoothing constant must always be between 0 and 1. That's also correct. So the answer here is B. Any questions before we continue? Okay, fantastic. Let's go ahead and look at exploring operations linear trend forecasting. Here we have an example of regression model, and here the regression equation is being approximated for us with these data. If we include 1 year worth of data all the way to 15 years worth of data. So question number 1 says, which of the following is least accurate? Okay, so the first one, when 8 years of data are used, the forecast for year 9 is higher than the actual value. So we can check that. This is 8 years, and you see that the forecast for year 9 is, this is year 9, is greater than the actual value, slightly higher than the actual value. So this is correct. It's not least accurate. When forecasting year 12 energy sales, the regression equation is 15.2 plus 0.27 times year. Okay, so when we are forecasting for year 12, it means that we are using 11 years worth of data, and you can see that this is the correct regression equation, 15.2 plus 0.27. So this is also correct. So this is not the answer. Now, option C, the model formula for energy cost using 9 years of data is the same as the formula for using 10 years worth of data. So we can check that. So if we use 9 years, it's going to be 15.2 plus 26 times X. If we use 10, it's going to be 15.2, again, 26 times X. So this is also correct. So by logic of elimination, D is our answer, but let's take a quick look at it. The R-squared value for the energy cost formula using 9 years of data is the same as R-squared when using 10 years worth of data. Remember that 9 years and 10 years, the equation is the same, but as you can see, if you look at the R-squared, you see that R-squared changes as we increase the data points that we are including in our regression equation. Our R-squared is also increasing. So that is not correct, and that's the answer to this question. Question number 2, which of the following is not true when comparing the use of 7 years of data relative to using 6 years of data? Meaning adding a 7th data point to the regression model. So we are comparing between 6 and 7. So comparing between these two equations, okay? But let's take a quick look. First option says that the amount of variability explained in the model increases. Okay, so let's take a look. If we are here at 6, you have R-squared of 0.91. When we go to 7, your R-squared actually decreases. So this is not true, okay? And this basically could be the answer, or it is the answer. So let's take a quick look at the other 3 and see if they are actually correct. The forecast for year 8 is higher than the actual value for year 8. So forecast for year 8 means that we are using 7 years worth of data. And you see that the forecast is higher, so this is correct. And then forecast for year 8 is about the same as forecast for year 7. Okay, so this is forecast for year 8, and this is forecast for year 7. You see that they are vertically speaking on the vertical axis, they are almost the same value. So this is also correct. And the forecast, the slope of the trend line decreases. So when you go from 6 to 7, you see that the slope decreases. This is a higher slope. And when you're using the 6 years data, and when we go to 7 years, the slope decreases. So that is also correct. So that's why option A is the correct answer. Any questions? Fantastic. Let's go to next part of our assignment, which is exploratory operations, moving average and exponential smoothing fit. So this is a little typo here. It says the title, just the title is a basically mixed with the other assignments. This is moving average exponential smoothing fit. However, this is a linear trend. So we are still working on regression. Again, we are working on the same graph. So here says that compare the regression line using 5 data points, the regression line using 11 data points. Which of the following statements is least accurate? Again, we are looking at the option that is not correct. So we are comparing 5 with 11. So this is the regression equation that we get for 11, and this is the regression equation that we get for 5. Now let's go ahead and take a quick look. Okay, it says that compare the regression line using 5 data points to the regression line using 11 data points. Which of the following statements is least accurate? So first one, the regression line equation for the 5-year model is 14.7 plus 0.43. So you can see that this is correct, 14.7 plus 0.43. So this is correct, and it's not the answer. The regression line for 11-year model is 15.2 plus 0.27. So we go to 11 here. I see that it's 15.2 plus 0.27. This is also correct. So that's not the answer as well. C, the amount of variation explained by the number of years for 5 years is less than for the 11 years model. So 11 years, you see that R-squared is 0.93, and for 5, it is 0.94. 95 almost. So this is not accurate. So we can say that this is the answer. Let's check D as well. The magnitude of the estimated trend for 5 data points is larger than that of 15 data points. So so you can see that this is for 5 data points, and this is for 11 data points. So the magnitude here is the slope basically is 0.43, and for 11, slope is 0.27. So slope decreases, or the magnitude basically decreases. So that's correct, that the magnitude for 5 data points is much larger than 15 data points. And this should be a typo. This should be 11 again, like all of these between 5 and 11. So which of the following is most accurate? The higher the R-squared value, the better the model predicts the next data point. Is this is correct or not? Let's discuss this a little bit, because it's a little tricky. Isn't it accurate? When R-squared is high, don't we have a better model? So a little hint, this is not correct. This is not the answer. And why is that?
Is it because it's the R is the variability? So the more variability there is from the trend line. Sorry, now I'm getting
very good, Sarah. Go ahead, continue.
Am I on the right track?
Yes,
if there's greater variability,
mm-hmm.
Then the model is not predicting the data as well.
Very good. You're on the right track. So R-squared basically says that what percentage of the variability in Y is explained by X. Okay, so if the R-squared is, for example, 90%, means that 90% of the variation in Y has been explained by X. It doesn't have anything to do with the predictability of the model. Okay, how do we know if model is better in prediction?
MSE.
Fantastic. So don't mix these two up. MSE is basically a value for error that shows that the prediction is more accurate or less accurate. R-squared is the amount of variation that is explained by this regression equation. Okay, so now let's go to B, option B. In general, especially as more data points are added, there appears to be about the same number of data points above and below the regression line. This is correct. This is basically the whole idea of least squares method. Again, as you remember, we have a trend, we fit this trend line in a way that the basically squared value of the errors, or the differences between the actual observations and forecasts, are the minimum. So that's why this basically is somewhere all the way in between of all these lines. So this is correct. So B is our answer, but let's take a look at C and D as well. C, as more data points added, the value of R-squared consistently increases. This is not true. Sometimes it increases, sometimes it decreases. R-squared has a specific formula, which is a little beyond the scope of our work. We use software to do all these calculations. And part D, for a variable like energy, that is generally increasing with the value of the independent variable, like year, as in this example, using more data always results in a larger slope of the regression line. That's also not correct. The slope doesn't have to do anything with the higher amount of data points that we use or not. It's basically the shape of the trend that determines the slope of a regression line. Now, question number 3, which of the following is least accurate? So for year 1 and year 2 model, R-squared is always 1 because all the variability in the dependent variable is captured by the model. That's correct. Again, as you can see here, if you use only 1, basically year worth of data or 2 years worth of data, R-squared is always 1. Everything that all the variation in Y is explained by the model. So this is correct. So it's not, the answer is not least accurate. So part B, the model with the weakest R-squared value is the 3-year model. So again, we can go ahead and check that. So this is the 3-year model, which is 0.82, and we can increase this and see if there's anything less than that. And we can see that this is also correct, okay? So this 82 is the lowest. So that's also correct. So it means that it is not the answer. C, other than the 1 year and 2-year model, the model with the strongest R-squared value is the 15-year model. Again, we can go ahead and take a look. You see that the values of R-squared are changing, and as we increase the number of years, we see that at 15 we have a much higher R-squared compared to all other previous R-squareds. So this is also correct, which means that it's not the answer. Again, by the logic of elimination, we know that D is the answer. However, let's take a quick look. The estimate for year 10, meaning using 9 data points, is the same as the estimate for year 11 using 10 data points. Again, this is correct. So we can take a look. 9 and 10, we see that both regression equations are the same. So this means that the estimates would be the same as well. So this is the answer here, and we are done with this part as well. Let's go and review the last interactive, if I'm not mistaken. Did we review everything? Yes. So the last one, which is a comparison between the moving average and single exponential smoothing. Okay. So let's go ahead and review this real quick together. Again, we have these two graphs side by side over top of each other. Basically, this is the moving average, and this is the single exponential smoothing. And we have these questions. It says that first, which of the moving average methods result in the smallest MSE? Okay, between naive, 2, 3, or 4. Again, we can take a quick look here. This MSE here is 11.91. 2 months is 6.78, 5.98, and 6.21. So 3 is again the smallest. What value of alpha minimizes the MSE for the exponential smoothing? Okay, so for the exponential smoothing, again, we move this and you see that pretty close to around 5. You see that we have the lowest value. So it goes down and down and down, and then after here it just starts increasing again. So see that somewhere around 55, we can say that we have the smallest MSE. Okay, so this is C. And then for the data given, what is the smallest value of alpha where the exponential smoothing forecast is more accurate, a smaller MSE than the 2-month moving average, alpha 0.3, 0.5, 0.6, or there's no such alpha. Okay, so 2-month moving average, let's take a look at the 2-month moving average. This is the MSE here, 6.78, and let's take a look. None of our MSEs is as low as 6.78. As you saw, the lowest MSE that we have in the exponential smoothing is just 9.6, and this is much higher than MSE, so we can say that there is no such alpha. And then finally, for what value of alpha does the exponential smoothing method have the same MSE as the naive forecast? Again, we know the answer to this one. Naive forecast is the same as alpha 0.1, and we can see that basically MSEs are exactly equal to each other because basically they are the same model. So that is also C, and that concludes our work here in these interactive graphs. Any questions that I can address? Fantastic. Let's go ahead and start working on our assignment. So we have one analytical assignment, and then we have 2 Excel activities and 1 conceptual piece of work. Now let's first start with the analytical work that we need to do. Okay. So question number 1 is asking us to calculate the MSE, MAD, and MAPE for this data that is available to us. Okay, let's go ahead and start a little Excel spreadsheet. And then we can go ahead and start building this together. So you can always copy these values and paste them here, and then do a little cleanup basically. So this is the customer satisfaction score. This is basically my A sub T. Are the actual values, and these are the forecast, which is my F sub T values. And then here I can go ahead and let's make them a little more concise and visually more appealing. So this is the data that we have. The first thing that we need to calculate is basically, in order to be able to calculate MSE, MAD, and MAPE, is to calculate the error. Okay. Again, as you remember, MSE, this is the formula for MSE that we will use. The formula for MSE has basically at the core of it, it has AT minus FT squared. So in order to calculate this, we need to calculate this AT minus FT. Okay. So error, which is A sub T minus F sub T, is going to be equal to this value minus this value, and I will copy it down. And again, those that I'm using a formula for, I'm going to put the formula here so you can refer back to these. So this is a formula that we used here for calculating error. And then we need to square these errors and then take an average of those. Okay. So next thing that we need to calculate is the squared errors. So this is my squared error, which is this value caret 2 or to the power of 2. And then I copy it down. Again, this is the formula that I used here. Okay, so now the rest is basically taking an average. We are adding all these up and dividing them by the total number of time periods. Or basically, we are taking an average. So we can say that, and close this down so we know what we are talking about. So here we are getting an average of all these values. So we say average. These are squared errors, and this is the formula that I used, and this is going to be my MSE basically. Okay. Now, next thing that I need to calculate is MAD, and please stop me if you have any questions. Next thing that I need to calculate is MAD. Again, for MAD, you see that here I have AT minus FT, absolute value of AT minus FT. So what I need to calculate is absolute error basically. So I go ahead and calculate the absolute error. And this is how we're going to show it. And that's going to be equal to ABS, or absolute value of this error that you have here. And then I copy it down. These are the formula that I used. And let's ignore this error. And finally, we need to get an average. So once we have all the values of AT minus FT, we just need to get an average of that. And that's going to be my basically MAD. So you see that my MAD is now 2.3. And then finally, I need to calculate MAPE. And MAPE, again, if you remember from the lecture, MAPE is given by this formula, which is basically the AT minus FT, or the error, divided by the actual value and the absolute value of that. Okay, so it's basically percentage of absolute error, or absolute percentage error. Okay, so this is going to be absolute percentage error, which is AT minus FT divided by AT. Okay, so this is my error divided by A sub T. Okay, now this is going to be basically absolute value as ABS, and I have AT minus FT over here divided by actual value, which is here. Copy this down. Now I have everything here. Next thing is to calculate the average. So I can go ahead and get the average here, and these are all the formula that I used. Let's take care of these error messages. And finally, one more thing that we need to do here is that this needs to be expressed as a percentage, or multiplied by, should be multiplied by 100. So what we need to do is change the basically format here to a percentage and use the number of decimals that is required by the question. 2 or 3 usually works. Okay, so this is our first question, calculating different measures of error for this data set, that this time series that is available to us. Okay, any questions? Okay, fantastic. Now let's go to question number 2. Question number 2 here, we have Cynthia's Design Studios that had sales the last 4 months of 13,700, 15,400, 17,150, and 18,850. Sales are related to how many designers Cynthia has on duty. The sales forecast helps her decide on the proper staffing levels. Round your answers to the nearest whole number. So here's asking what is the forecast for the 5th month using a 2-period moving average, and what is the forecast for the 5th month using an alpha of 0.9. So we're using this data in moving average and as well as single exponential smoothing. So let's go ahead and use the templates that are available to us. So here, first we have the moving average. Let's go ahead and use this template. Okay. So what I'm going to do, I'm going to go ahead and remove all the data that is available here, and then look at my question. Okay, so my question says that use a 2-period moving average. So basically means that my K is 2, and my data points are 13,700, 15,400, and 17,150, and 18,850. So I can go ahead and do a little copy and paste here and enter these values: 13,700, 15,400, 17,150, and 18,850. And that's it. Basically, I'm done. This is the forecast for month 5, which is 18,000, and this is my MSE using the moving average technique. Okay. Now, it's asking me to do a forecast for the 5th month using an alpha of 0.9. Okay. So now let's go ahead and use that. So we're going to go ahead and use the exponential smoothing template. Let's go ahead and get the exponential smoothing template. So again, let's go ahead and enter this data that we have. 4 periods worth of data. And so this is my data points. And I know that my alpha should be 0.9. Okay, so I'm good. I can go ahead and say that, okay, this is the basically forecast for month number 5. Let's go ahead and check this and see if this is correct. Okay, let's go ahead and check it here, and no, it's not correct. What's wrong? What did I do wrong? Take a look at the question real quick again. Find the error for me. Go ahead. Read.
Are you using the 0.9 smoothing? A equals 0.9?
Yes, yes, I'm
Oh,
using
okay.
0.9. Oh,
My bad, my bad.
No, it's okay.
The values for A4 and F4 are different.
Fantastic. So you see that A4 is 18,850. Okay. So this is A4. This is correct. Okay. Our F4, here I have 16,983. Okay. This is different from this forecast. So I need to overwrite this manually. Okay. 16,983. Okay. That's basically what I overread manually. Now you see that my forecast for month 5 is going to be different. Let's check that and see if this is correct. Yes, this is correct. Okay, so a little hint, sometimes when you have a specific value for a forecast, means that it's an adjusted value, you need to incorporate those. And again, a little technicality, if you are using the templates that come with the book are available on MindTab, you cannot do any of these. You cannot change the numbers besides the yellow cells. Okay, so it's always a good idea to use the templates that I have uploaded on Moodle. Those are the instructor versions, and you can do whatever you want with them, basically. Okay, any questions? Are we good? Okay, fantastic. Let's go to question number 3.
Sorry, I have a quick question.
Sure.
For the formula for the forecasting month, sorry, back on the sheet. If you click on for month 5, the forecast for month 5.
So forecast for month 5, we overread this. Okay.
Oh, sorry, down below.
Okay. So you want to know what is the formula that goes here?
No, if you scroll down a little bit. Sorry. Next to time period 5, and where the 1863. Yeah, is that what? Sorry, this is not the right place or time to ask this, but what is the index?
Oh, so don't worry about that. Don't worry about that. It's basically, if I want to go into index and match, it's going to be a little too much Excel course. So basically what has been done here is that this formula has been basically automated to a great extent. Okay, so this is the formula that we use here. And this has been basically, you see that this 1 minus alpha is right here, and your alpha is right here. But since it's a very automated template, so just you enter data and you get the answers, many of these values of t minus 1, and so on and so forth are being calculated using some advanced Excel formula. Okay, so if you're interested in knowing what is index and what is match and what is basically count and so on and so forth, I can send you a couple of videos that explain those really extensively.
Okay, I just wasn't sure if we would need to build these templates for any questions at any point.
Not at all, not at all.
Okay.
For any of the questions, you don't need to worry about any of the formula that are entered here.
Okay, thank you.
Sure. And question number 3. So here we have Exotic Wines Incorporation wants to use exponential smoothing with alpha of 0.5 to forecast demands in bottles sold. The demand for the last 4 months, there's a 4 missing here, are such and such. The forecast for bottles was 2,321 bottles for second month. What is the forecast for the 5th month? Round your answer to the nearest whole number. Again, here we are doing a single exponential smoothing. My monitor stopped working. Give me 1 second. I have a faulty cable, I guess. Let's see. I think I'm back. Okay. I assume that you can see me and hear me now. Fantastic. So this is again an exponential smoothing question. So we have these values from 2321 all the way to 4412. And we need to use the single exponential smoothing template to solve this problem. Okay, so I'm going to go ahead and use this again here and a special. So let's change this back to when the formula was there, and then pay special only the values. And here we just need to double check that this 2321 is correct. This is the value that has been instructed for demand for the last month. I'm sorry, the forecast for bottles for second month was 2321. We need to double check that. It's always the same this, but for month 5, we want the forecast, which is 5669. I'm sorry, we need to change this to 0.5. And this is going to be the forecast 10,697 and half. Let me see if I made any mistakes anywhere. Yes, this is not correct. Okay, so this was the overridden value that we put there. So now everything is correct. So I have a 0.5 here, and for the 5th month, my forecast is going to be 3732. Go ahead and enter that and check if everything is correct. Any questions? Now let's go ahead and review question number 4. A linear regression model is units equal to 3,309 minus 0.779 times week. For week 47, what is the forecast of the number of units? This is a very straightforward question. Again, you have a equation and you're plugging a number in it just for the sake of being through. I'm going to go ahead and solve it. So here we have a these are my values, 3,309 and 0.779, negative 0.779. Okay, so I know that my intercept is 3,309 and my slope is negative 0.779. And the number of weeks that I'm interested in forecasting for is 47. I want to find out what is the forecast. So it's going to be basically the intercept plus the value of the slope times the value of x, which we are looking for, and that's going to be basically my forecast for month 47 or period 47. And this is the formula that exists. Okay, very straightforward question. Now, question number 5. Here we have Canton Supplies, which is a service firm that employs approximately 100 people. Because of the necessity of meeting monthly cash obligations, the chief financial officer wants to develop a forecast of monthly cash requirements. Because of a recent change in equipment and operating policy, only the past 7 months of data are considered relevant. The change in operations has had a great impact on cash flow. What forecasting model do you recommend? Okay, so basically you see that here, it's up to us to find out what forecasting model we should use. Use the moving average and exponential smoothing templates or other Excel tools to help you answer this question, okay? So first, we have been asked for MSEs of different moving averages and to find out which one is the best, and then MSEs for different alphas, and also for a regression model with the MSE, need to find out, maybe compare these 3 models and find out which one is the best model, okay? So let's go ahead and start working on this. First, we need to do a basically moving average. Okay, so I'm going to go ahead and use the moving average template. So this is the moving average, and my values. Let's go ahead and copy and paste this. And paste it, for example, here. Okay, so these are my data. So from 192 to 196, let's go ahead and paste only the values here, and then get rid of all this. Don't need them. And let's review it one by one. So if we have a K of 2, this is our forecast and this is our MSE. So let's take a note of these somewhere. So for example, here, I would say that this is my values of K. What is going to be the value of MSE? Build a little table for ourselves. So we do values of K, 2, 3, and 4. And we want to compare these in terms of the value of MSE. So for 2, our MSE is 759.05. Let's take a note of that. And then if we change this to 3, see that our MSE changes to 1257.83. Paste this here. And also if we change this to 4, this will be 591.90. So this is the final value. Okay. Again, number of decimals and so on. And you can see that here between these 3, 4 is the best model. Okay. And again, let's go ahead and check one of these and see if we are answering everything correctly. So this is correct. And you see that 4-month moving average is the best model. Now we need to run the same data in the single exponential smoothing and with all these different values of alpha from 0.1 to 0.9. Okay, let's see how we can do this. Again, data that they have is from 192 to 196. So that your values might be different, are different from this. So let's paste all this. And let's just start with value of alpha 0.1. Okay, so let's build a little table again here for values, the different values of alpha and different values of MSE. Okay, so this is alpha and this is MSE. Okay, so what I can do is I can go ahead and do one by one. For example, for 0.1, I see that it is 1295. For again, I can go ahead and plug in 0.2 and read the value and so on and so forth. And it's going to be very time consuming. And even if so, here I have only 10 numbers, and it's doable like in a few minutes. But if I have like 100 numbers that I want to plug in one by one and get the answers, it's not going to be very efficient. So what I can do is to use a Excel function called data table. Okay, so what I will do first, I will build my 0.1 to 0.9. Okay, and just for the sake of increasing the number to make it a little more interesting, let's see that we are doing this at the intervals of 0.5. Okay, 0.05. So we have all these different values of alpha. Suppose that the question is asking us to calculate the MSE for all these values of alpha. It's going to be very time consuming if we want to plug in one by one here and calculate. But Excel can do this for us. Okay, so what we need to do is to say that, for example, for 0.1, this is the answer. Okay, so I will say equal to this value. Okay, so what I'm doing is that, let me make this a little. So this is the one another use. Okay, so basically here I am saying that this value corresponds to the value that I want to get from E30. Okay, then what I do, I will select everything here. Okay, like these two cells. Okay, and then I would say that I would go to data and I click on what if analysis. And I click on data table. Okay, so far we have used goal seek. Now we are using data table. Click on data table and say that, okay, I want you, right, I'm telling Excel that I want you to go ahead and take this column, okay, the values that you see in this column, take these and enter them one by one here. Okay, so forget about row input. We don't have rows. We have just one column. So I'm telling Excel to get these values from 0.15 all the way to 1 enter them here, and then read the value that you get in E30. Okay, I OK the way, and I get all the values of MSE with just one click. Okay, and then I can highlight the one that is lowest. So I can go ahead and click on conditional formatting, and here I can find the smallest value. So I can say they can show me the bottom first value, and you see that this is the lowest amount. So 0.7 is giving me the lowest MSE. Still, this MSE is higher than the MSE that I got here in the moving average. Okay, so far I have taken care of the moving average with different values of K, 2, 3, and 4, and different values of alpha, and found out that 0.7 is the lowest value. Alpha of 0.7 is the lowest MSE. It gives me the lowest MSE. Okay, so this is, again, let's check this and see if this is incorrect. And then need to find a regression model. Okay, so again, we are using the same data and we are building a regression. So here I'm going to do it two different ways, okay, to answer a few questions that I have received from you. Okay, first let's go ahead and do it this way. Okay, so paste special and paste values. Okay, so this is my data series. So I click on data, I click on data analysis, and then I click on regression, click OK, and first I input my Y range, which is here, and then I have my X range, which is here. I don't have labels in the first row, and I want my output to be, for example, here. Okay, and that's that. Okay, OK the way, and I get this regression output. Okay, so these are the values that we are interested in mainly. Okay, so our coefficients are basically, so my regression equation is basically going to be y equals to 216.71 plus 1.57 times x. Okay, so this is my regression equation. I can go ahead and check this and see if this is correct. So for example, this is my intercept, and this is my slope, and MSE. So MSE, remember from the lecture that you can find the value of MSE right here. So this is MS, and this is due to error or residual. So this is the value of MSE. Let's go ahead and enter that here and check this work and see if everything is correct. Okay, so value of MSE is not correct. It's in two decimal places. So for some reason, this is not giving me the correct answer.
I had the same problem. I also got the correct number, but for some reason it just didn't accept the answer.
Yeah, same here.
So you use the same
Same
thing?
here.
This should not happen. Let me run intermediate calculations. Yeah, it could be an error, but let's try it in a different way. So here we have the let's do it the basically traditional way. Okay, so these are my time periods. Okay, and here my I have values of a sub t. Okay, and let's here we have value of f sub t. Okay, and f sub t is basically based on these two. I can go ahead and calculate them. So f sub t is going to be basically this intercept plus this value times the slope that I have here. And then I will lock the slope and also lock the intercept because I want to copy it down. Okay, so I'm going to go ahead and copy this down, and this is the formula that I used here. Okay, so I'm basically calculating ft based on this regression equation that I just got. Okay. So formula. And then I go ahead and calculate the ft minus at minus ft. Okay, so this is going to be my error. Okay, t minus ft, and it's going to be equal to this value minus this value. Okay, so this is not. This doesn't seem to be accurate at all. Let's see what's happening. Okay, made a mistake. So it should be A1, A2 basically. Okay, so this is my X, this is not my X. So that was a mistake. So fix that. Now this is correct. Now this is my AT minus FT. Copy it all the way down. And then I need to get the AT minus FT squared. Okay, so AT minus FT squared. Okay, which is going to be equal to this value to the power of 2. Okay, and then copy everything down. Okay, now if I get here's the interesting part. Basically, there are two different approaches, which one is more accurate. Okay, so if I get the average of these, this is basically going to be my MSE. Okay, so let's go ahead and get this average of all these, and you see that it is 513.26, which is quite different from the 718. Okay, so let's do it in 2 steps. First, let's get the sum here. See that this is the sum of these values. Okay, and then get the average. Okay, I will explain why I'm doing it in 2 steps. So this is the sum and this is the average. You see that this average is quite different from this average. Okay, so let's try this as well, see if this works. Yeah, this sounds problematic. Don't know. Didn't happen in the past, but anyway, so this is the correct value of MSE. Okay, this is the correct value of MSE. Since it is not accepting it, let me go ahead and do it one more time. Let me see if this is giving me the same wrong answers. So data analysis, regression. I checked this a few times and was not error sum. Okay, I have labeled this time, and suppose that I want the second summary here, and everything else is correct. So 718, yeah, exactly the same. Okay, so there must be an error. Again, I checked it a few times and it didn't give me this error, but it's giving me this error now. Now, this is the correct answer. Okay, so I will go ahead and manually overwrite the grade for everyone. Now, tell me why these two numbers are different. Okay, because this was the question that I received from a few of you that were calculating the MSE the manual way, basically, or semi-manual way using the formula, or using this Excel basically tool. Why these two are different? Anybody knows? Okay, now let's take a look at this number. Look at this number. and this number. What do you see?
They're the same.
They're the same, okay? This is the sum of squares, okay? So sum of squares, so sum, and these are all squared errors. So SS that you see here is sum of squares, and residual is the same term for errors, okay? So this is the sum of squares, okay? And you see that this, now here, I divided this by 7, okay? Because I have 7 time periods, okay? So this average basically is this divided by 7, okay? Now let's see if I divide this by 5, okay? So I have a 5 here, okay? So you can see if I divide this by 5, what happens, okay? If I get this value and divide it by 5, you see I get exactly 718, okay? What's happening is that MSE, when you're calculating MSE for regression equation, instead of getting the sum of squares and dividing them by n, which is the number of time periods, you divide them by n minus 2 for a simple linear regression, okay? N minus 1, n minus 1 minus 1, okay? Minus 1 is, the first one is basically the number of independent variables. Second one is for the degrees of freedom. Again, this is going to be a little beyond the scope of our work. It's too much statistics. Long story short, whenever you're calculating the MSE for regression, don't use this formula. Or if you're using this formula, if you have one independent variable, make the denominator n minus 2. If you have 2 independent variables, make it n minus 3 or so on. Or if you want to be safe, just use this tool and read the MSE from here, okay? How many of you had problem entering this and getting a wrong answer? Just give me a thumbs up with your Zoom thing. Anybody was able to enter the answer and get correct answer?
Yeah.
Okay, so it's I guess it has something to do with the algorithm, because I also solved this a few times and I got the correct answer, but now in class I'm getting the wrong answer. So I guess it has something to do with the
Oh, I did.
Santiago?
Yeah, I did. I did get it right. So
Yeah.
for the MSA, what I did, I used the data analysis tool in Excel.
Mm-hmm.
And then instead of using the big number, I used the 359. I think you also got calculated it. So the one for the one before, 3592. I believe that's the one I used.
Okay, are you dividing by that?
No, I just the number is straightforward.
Oh, you use that number?
Yeah, I started just plugging numbers out of the ones that I had, and I think that one worked out.
No, it doesn't work here. That's interesting. Okay. Anyway,
it was one of those. That's what I ended up doing. I ended up getting a different error number, and I just thought that was the way to do it.
Yeah, this usually works. I mean, this is the first time that I'm seeing this error. Solved it for different classes, and it's working. But anyway, I will give the grade for everyone for this. And whenever you are doing the MSE for regression equation, long story short, your safest bet is to use this technique and just use this MSE. Okay. Again, so even if this is correct, 718. You see that the lowest MSE is still this basically this is 873, this is 718, and in your moving average you had 519. So your best model is a moving average with K of 4. Okay, that's the model that you should go ahead and use. So far so good. Any questions here? Fantastic. Now let's go ahead and continue our work. Go to question number 6. So here I have forecast and actual sales of digital music players to July. Sales music, same music are as follows. Just Say Music are as follows from March to October, and we are using the moving average template to basically first find the graph and then find the the forecast for November using a 2-period moving average and a 3-period moving average and compare the MSEs. Again, this is a rather straightforward question. Let's go ahead and solve it anyway. So this is my moving average template. Let's go ahead and use these values. This is my forecast and this is my actual sales. So I need to just use the actual sales values. Paste them. Here, and then I need to do a graph. Okay, so a graph to compare the basically forecast data and the actual data. So for this, I can go ahead and use this data set that I have and go ahead and click on insert and click on a scatter diagram and use this one that connects them to each other. And that's basically is going to be, it's going to be my chart. I can go ahead and compare this chart that I have here with these different charts and see which one is the correct answer. Okay, so as I can see, this one is pretty close to this last one. This 170, I missed that 170 here. That here as well, yeah. So you can see that it is very close to, it's either this, no, this is not it. So this is the last one, D. Okay, so D is the correct graph. I can select that. And then let's check this and see if everything is correct. And then we need to compare forecast of November using a 2-period moving average and a 3-period moving average. Okay, so first let's do K equal 2. Okay, so change K here to 2. And you see that for November, I have a forecast of 190. Let's check this. And then for 3-period moving average, I will change the K to 3. I get 200.33. And then I need to compare MSEs as well. So MSE here is 769.33. And if I change this to 2, my MSE would be 486.29. So that's the comparison between these two. And again, as you can see here, my 2-period moving average is a much better model because it has lower error as shown by the mean squared errors. So that's this question. Any questions on this? Let's go to question number 7. Okay. So question number 7, a restaurant wants to forecast its weekly sales. Historical data in dollars for 15 weeks are shown below. Use Excel and the moving average template to answer the following questions. Again, we need a graph and also forecast for week 16 using a 2-period, 3-period, pretty similar to the previous question. Okay, just for the sake of being through, let's go ahead and solve this. So this is my data, and if I need to plot this, is just getting a scatter plot. Okay, so this is my observations. I can compare it with these graphs and see which one is the correct one. As you can see, it's pretty similar to A, option A. So I can say that A is the correct answer. Go ahead and check that. And then let's go ahead and see for week 16, if you use a 2-period moving average and a 3-period moving average, what happens, okay? So here, I'm gonna go ahead and use these observations and enter them here. And then for 2-month moving average, this is gonna be my forecast, 1508. And this is gonna be my MSE. And then I change this to 3. And I get a forecast of 1565 and a MSE of 36,744. Okay, let's check this as well. So everything is correct. And as you can see here, my 3-period moving average is a better month. Okay. Any questions? Oh, we're all good. So now let's go to question number 8. So question number 8 is says that the president of a small manufacturing firm is concerned about the continual growth in manufacturing costs in the past several years. The data series of the cost per unit for the firm's leading product over the past 8 years is as follows. Choose the correct graph for the time series, and then after that, we need to basically develop a regression equation and find the average cost increase per year. So it's basically a regression question. So let's go ahead and use this data, open a new sheet, and let's tidy up this data here. So these are my X and Y values. So I can go ahead and use the Excel built-in tool for calculating, performing the regression analysis. So these are my Y values, and these are my X values. And I have labels in the first row, and I want the answers to be plotted in here. And I here go ahead and click on the line fit plots. Okay, so line fit plots basically gives me a scatter plot of X and Y, especially if you have only one independent variable, is going to be quite helpful. So click OK here, and this is going to be my line plot. So I can do a little tweak here to make this similar to what I need. So I need to change this to, for example, a scatter plot like this. So this is going to be my fit line, and this is going to be the basically observed values. So I can go ahead and compare this with these different graphs that I have here and see which one is closer to this. Okay, so again, I can see that it's pretty close to option A, if I'm not mistaken. Yep, option A seems to be the correct answer. Let's check this. This is correct. And then let's go ahead and continue our work. Then it asks for the regression equation. So regression equation, I have them here. This is my intercept, and this is my slope. So my intercept is 18.02. I can enter it here. And my slope is 1.56. I can enter it here. And then finally it says the average cost increase per year. What is the average cost increase per year?
$1.56.
Fantastic. Okay. So the slope is basically the annual increase. That's your variable cost. Basically, your intercept is, you can think about it as your fixed cost, and your variable cost, year-over-year increase. Okay, so this is basically the cost increase per year. Okay, if you're not sure, just go ahead and plug in 2 different values for x, a value of 3 and value of 4, and compare them. You see that the difference is going to be this, because basically the intercept is going to get canceled, and the difference between x is going to be 1, and 1 multiplied by slope is going to be the slope. So that is that for all these 8 questions. And then when we go into our case study, you will see how we are using all these assignments that we have done. So it's not just something that we are doing to do some like statistical analysis or so. We are using these different techniques that we have learned in forecasting in our case study, which we will review in a second. Now, we are done with the assignments. There are 2 Excel activities here. Let's go ahead and review them quickly. First activity is a moving average. Okay, and there's a video that walks you through this step by step. We are basically building the template that you are using, a very a simplified version of the template that you are using. We are building that. Okay, so we are going to go ahead and start working on this. Okay, so for moving average, here we have the periods, and moving average is 3. Okay, and we want to go ahead and calculate basically the forecast. So as you know, the moving average is basically the average of the kth previous observations. Since my k is 3, it's going to be the 3 previous observations. Okay, so forecast for month 4 is going to be the average of month 1, 2, and 3. And then I can copy this down. So this is going to be all the way. So these are all the averages, and also for month 13, it's going to be the same thing. Okay, it's going to be the average of the 3 previous observations. Okay, so that's basically the forecast, and error is going to be the actual value minus the forecast, and I can copy this down as well. And then error squared is going to be this value caret 2, and these are the basically squared errors. And then finally, I can go ahead and calculate my MSE, which is the average of all these error squared values. Okay, you see that my MSE is 19.5. So let's go ahead and check this and see if everything is correct. So this MSE is correct, and now it asks me for a basically a graph for this 3-period moving average. Okay, so for graph, I can go ahead and just get the values of demand and forecast. Okay, for all these 13 periods. Okay, I can also choose the time period as well, and then go ahead and insert a scatter plot, which is connected with lines. And this is going to be basically my graph here. Okay. So, and then we can go ahead and compare it with different graphs that I have here and see which one is the correct answer. And it asks for which forecast is the best based on MSE. So you need to do 4-period and 3-period and compare them and find out which one is the best. Okay, so this was for 3-period, and then you need to continue this for 4-period. So I have to repeat this whole thing, average of these 4 previous periods along with the last one. Again, error is AT minus FT, copy all the way down, and also this caret 2 will give me my squared errors, and average of all these would be my MSE. Okay, and then I can write a little f function to compare these 2 And that's not a big deal. You can just go ahead and do that. And again, if I go ahead and calculate, select everything here and build a little scatter diagram connected with dots. This is going to be my chart. And again, I can compare this chart with the correct answer. And again, between these two MSE, you see that 3 period is a better option. And then you can go ahead and say that, okay, this is correct. And this is the correct answer. All good? Any questions here? Fantastic. Now let's go ahead and continue our work to our last work, Excel activity exponential smoothing. Okay, here we have same basically material. The difference is that we have single exponential smoothing. Okay, so for single exponential smoothing, we are using the formula that we have to calculate the forecast. Okay, so if you remember, the formula is basically alpha times AT plus 1 minus alpha FT. Okay, so I will write it somewhere for you here. I guess it's a protected sheet, so I cannot write anything. Okay, I can write here. This is good. So this is the formula. So I know that FT plus 1 for the next period, okay, is equal to FT, the forecast for this period, okay, plus alpha, or let's use the other one. Okay, this is much easier. Okay, you can say that alpha times the actual value of this period. So alpha times the actual value of this period plus 1 minus alpha, the forecast value for this period. Okay, this is an easier way to basically conceptualize this formula. Okay, so again, as you can see here, I'm assigning a weight of alpha to the actual value of this period for the next period, and 1 minus alpha to all the previous ones. Okay, so for example, if I have a 0.2 alpha, I'm giving 20% weight to this most recent observation and 80% weight to all the other observations. All the other observations are basically conceptualized in FT. Okay, FT is also basically calculated based on this, so it incorporates all the values in the past. So now let's go ahead and use this formula to calculate the forecast. So this is equal to alpha, and I'm going to copy it down, so I need to lock it here. So this is my alpha, and then absolute cell reference times my observation that I have here. Okay, actually, I made a mistake. So for the very first one, it's always the case. For the very first one, for the first time period, it's always going to be the same as the observation. Okay, so for basically single exponential smoothing, it's always going to be the same. So 93 and 93. And for the second one is also going to be the same. So you can go ahead and either enter it manually or use the formula. Either way, it's going to be the same. It's kind of for the first and second period, it's going to be exactly the same as the first observations. So we can go ahead and use the formula. So this is the alpha. I'm going to lock it times a sub t, which is the value that I have here. Okay, and then so a sub t. So this is ft plus 1. If this is f2, this is going to be a1. Okay, so alpha times a1 plus 1 minus alpha. Again, I will use absolute cell reference f1. Okay, so f1 is here. Okay, again, you can see that since these two are equal to each other, 93 and 93, C3 and C6 and D6 are both 93, and this is alpha and 1 minus alpha. This addition of these two is just 1, so it's basically going to be 93 again. But going forward, it's going to be different. I can use the same formula. Going forward, you see that it will be different. And finally, I will get the value of forecast for the next period. And errors, let's go ahead and calculate the errors as well. So for the first one, I have an error of 0. Let's see if I made a mistake. Everything is correct. So that's it. And then I have the error squared values. And finally, my mean squared error is going to be equal to the average of all those squared errors. Okay, so which is 18.19. I can go ahead and use these, and I also can use these 3 columns to build a little graph. This is going to be my graph is again, it's going to be all the same technique, and I can compare it with the correct answer. So any questions on the Excel activities? Oh, we are all good. Okay. So we have what is remaining is the conceptual piece of our work and then our case study. Okay, so let's review the conceptual part real quick together. It's not a big deal, but it's going to be good jogging our memory on the concepts that we have covered in this chapter. And then I'm going to go ahead for this. I'm going to go around the class and use my screen, as I can see here from top left. I will start. Okay, so question number 1, in the context of data patterns in a time series, blanks are characterized by repeatable periods of ups and downs over a short period of time, random variations, seasonal patterns, cyclical patterns, or irregular variations. Sarah, go ahead.
Seasonal patterns.
Very good. It is a seasonal pattern. Again, as you remember, gas consumption, ice cream sales, and so on and so forth. These are all examples of electric bills and so on. In the context of forecasting errors, blank eliminates the measurement scale factor. Normalized means signed deviation, mean absolute deviation, normalized root mean square error, or mean absolute percentage error. Lenora, go ahead. You are on mute.
C.
Normalized root mean squared error. Hernan, what do you think?
Or mean absolute square error. D.
Fantastic. That's correct. Mean absolute percentage error. Remember, MAPE, which is mean absolute percentage error, is the only one that basically eliminates the measurement scale. Remember, MSE and MAD, they could not be by themselves. They don't mean anything, and they need to be compared to another model. MAPE, however, since it basically eliminates the measurement scale, can be used on its own to say that there's this much percentage error here in this model. Question 3, in the context of data patterns in a time series, a blank variation is a one-time variation that is explainable. Hernan, go ahead.
Irregular.
Very good. Irregular variation that we talked about, things like hurricane, a disruption of like type of COVID-19, or a war that breaks out, and so on. Blank is a common approach to gather data for judgmental forecasting, a moving average model, regression analysis, survey questionnaire, or single exponential smoothing. Kim, go ahead.
A survey questionnaire.
Fantastic. That's correct. The survey questionnaire is one of the methods that we use for gathering data for judgmental forecasting. Blanks are necessary to plan for facility expansion, long-range forecast, intermediate range forecast, make-to-order operations, or make-to-stock operations. Alicia, go ahead.
It's long-range forecast. A.
Fantastic. Long-range forecast, when we have a facility expansion, it's usually for a very long period of time, so we have to do a long-range forecast. Blank is a forecasting technique that uses a weighted average of past time series values to forecast the value of the time series in the next period. So, Marianella. Marianne.
Okay. A moving average forecast.
A moving average forecast. Kristen, do you agree?
I put single exponential smoothing.
Fantastic. So see, the key here is weighted average. Okay, weighted average of past time series puts more weight on the most recent observations, weight on the previous observations. So question number 7, forecast blank is the difference between the observed value of the time series and the forecast. Reed, go ahead.
Error.
This is forecast error. Very good. Thank you. Alex, take this question, please. If the time series is an exponential smoothing model exhibits a negative trend, the mean squared error will be negative. The value of the smoothing constant will either be less than 0 or greater than 1. Forecast will overshoot the actual values. And finally, the future forecast will rely solely upon expertise of people in developing forecasts. Alex, you're not with us. Jacob, can you take this? Tommy, can you take this?
Yeah, it's a forecast will overshoot the actual values.
Fantastic. So this is something that we need to keep in mind when you're using SES. When the trend is negative, it usually overshoots the actual values. It's the characteristics of this model. A blank is an underlying pattern of growth or decline in a time series. Christian.
Would be a forecast error.
Forecast error. Santiago, do you agree, disagree?
I didn't put forecast error. I went for a trend.
Trend, very good. Trend is underlying pattern. When keyword here is pattern, when you see an increase or decrease or exponential and so on and so on, linear, non-linear, that's going to be a trend. In the context of forecasting, the term blank refers to the tendency of the forecast consistently be larger or smaller than the actual values of the time series. Trend, bias, fad, or variability. Jason. Jason, are you with us?
Is B, bias?
Fantastic, that's correct, bias. Question number 11, moving average or MA method works best when the long planning horizon is involved, cyclical pattern is observed, demand is relatively stable, and there is a major trend in the time series. Sarah Isabel.
I put C, demand is relatively stable and consistent.
Very good. So this is one of the characteristics, one of the basically assumptions of using this model. If the demand is stable and consistent, we can use MA technique. Question 12. Blank is a method for building a statistical model that defines the relationship between a single dependent variable and one or more independent variables, all of which are numerical, Delphi method, regression analysis, judgmental forecasting, or the Cook method. Where were we? Christina. Christina, are you with us?
Is it regression analysis?
Very good, regression analysis. Question 13, blank is based on the assumption that the future will be an extrapolation of the past. Judgmental forecasting, statistical forecasting, Delphi method, or Cook method. Peter.
Is it B?
B, fantastic. Statistical forecasting. Remember, we had statistical forecasting and judgmental forecasting, and then we had the regression analysis as well. When no historical data are available, blank is sole basis for predicting future demand. Statistical forecasting, regression, judgmental forecasting, or exponential smoothing. Jensen, go ahead.
I got judgmental forecasting.
Very good. In absence of data, we will use judgmental forecasting. Question number 15. Blank are needed to plan workforce levels, allocate budgets among divisions, and schedule jobs and resources. Fernando, which one is the correct answer?
I picked B in intermediate range forecast.
Intermediate range forecast, that is correct. So these are all the activities that need intermediate range forecast. Okay. And a tracking signal provides a method for monitoring a forecast by quantifying bias, throughput, probability, or validity. Bijan?
Yeah, I got a bias.
Fantastic, that is correct. And question 17, in the context of data patterns in a time series, regular patterns in data series that take place over a long period of time are called blank pattern, orthographic, seasonal, cyclical, or parallel. Hannah.
Yeah, my Safari is having issue right now, but I think if I remember right, is it cyclical?
Fantastic. The cyclical, very good. I remember the example was from stock market, if you remember from the videos. Question number 18. Here we have blank are used by operation managers to plan production schedules and assign workers to jobs. I have Josh, go ahead.
Short range forecast.
Short range forecast, that's correct. So this is production schedule and assigning workers. This is a short range. In the context of the fairly stable time series with relatively little random variability, which of the following statement is true of single exponential smoothing? Geraldine, go ahead.
A.
Very good. I see that values of 0.5 put more emphasis on the recent data. Value of constant larger than 0.5 take place more emphasis on the recent data. You can remember from the formula that we had alpha 1 minus alpha. Alpha is the value that we put for the weight of the most recent observation, and 1 minus alpha is going to be for basically the forecast of this period, which carries along all the previous observations. So that's conceptualization here. And then the Delphi method of judgmental forecasting. Jeremy, can you take this last question?
D.
B as in boy or D as in David?
D as in David.
Very good. Experts are not consulted as a group to make predictions. They're not consulted. So what's going on? Why do we need to ask them for their opinion? Why do we need them? Go ahead. You know the answer. It's not a trick question. And this is a question for class.
They're not consulted in a group. They're
fantastic. That's
individually, and their answers are blind, basically, to the others.
Fantastic. That's the correct answer. So basically, the whole idea is conformity bias and evading the conformity bias. Now, let's go ahead and start working on our case study. Okay, so while I'm loading the case study here, let's go ahead and see. So while I'm loading it, please go ahead and tell me what was the story, what was happening. Bank USA.
They received a call from the client with a complaint that they had a wrong share price. Which resulted in 42,000 lower than It should be.
That's correct. So that's correct. That's basically the problem that has happened. And what is the little data set that we have here? What is the point of this?
Help desk call volume.
Help desk call volume. Okay. And why do we need to use this? What do we need to do with this?
They're trying to forecast the next few days of like the call volume so that they can better prepare themselves and their company.
Very good. How does it help? How does it help with this situation that we are in?
Reduces call time or waiting time, my bad.
Reduces call time. Just by forecasting, we reduce
Waiting time, sorry. If you need to bring more employees in to reduce the waiting time.
Fantastic. So if we need to, so we will be well prepared basically in advance. If we need more employees, we can plan ahead and hire some more people or put people on overtime use and so on and so forth. Okay. So I have a few questions here. First question is that what are the service management characteristics of a CSR job? CSR is customer service representative. So what are some of the characteristics of this job?
Talking with customers, answering their questions.
Very good. Okay. Is it a lucrative job? What the skills they need to have, and what are some of the characteristics of performing such a job?
Need to be patient.
Very good. You're always dealing with angry people who are frustrated and have problems, and they have no one else but you to basically transfer all their stress and frustration. Their job is heavily monitored. They have usually it's electronically done and it's electronically monitored. Compared to what they do, the pay is not very high because it's not doesn't have very high analytical skills, doesn't require very high analytical skills or any other type of skills. It's very stressful. They need to show empathy to the customer. They need to be very patient, need to sit all day. And most probably supervisors are listening on their calls. There's no privacy, and it's not very healthy and very stressful job. Okay, compared to most other jobs, it's very stressful and unhealthy. So question number 2 says, define the mission statement and strategy of the help desk contact center. Why help desk is important and who are the customers? So customers are usually from inside the bank or inside the institution in this example, as you can see. And a typical mission could be to provide accurate and timely resolution of customer problems and inquiries for the bank, for example. Okay. And this question number 3 is rather important. How would you handle the customer affected by inaccurate stock prices in the bank's trust account system? Would you take a passive approach or a proactive approach? Justify your answer. Okay, so here you know that the problem that happened was basically there was an error that resulted in as Alisher mentioned, if I'm not mistaken, resulted in a very high discrepancy. So let's do a little brainstorming here. Let's discuss this. How should we fix this? How should we address this problem?
I would take a proactive approach and work with my team manager and make sure that the client is contacted by the promised time, which is the end of the day, I believe. And ensure that I have all the information that the client is asking for in regards to the correct calculation and how the credit or the error will be fixed.
Fantastic. Very good. So this is correct. So first we need to look into the problem and see if this is actually an error. And if this is the error, first we need to apologize and send a corrected counter statement. Need to be proactive and search for all other accounts, looking for to see if this is a systematic error. Maybe there is a problem with our software or operations or manpower and so on. And then finally, we need to call for a meeting with the appropriate system and support and retail and backroom and so on and so forth to do a root cause analysis, basically, and find out what was the exact basically main root cause of this problem that created this error. Okay, and then finally, this part of our case question is analytical. While using the data on call volume in the table, how would you forecast short-term demand? Okay, so this is going to be basically a combination of all the methods that we used here in this technique, okay, in this class. So yeah, let's see if we have enough time. So I'm going to go ahead and use this. So first, let's go ahead and do a moving average. Okay, or actually, let me go ahead and use the pre-built. That's much easier. So this is the data that I have. Okay, so this is this data from 204 to 500 from day 1 to 16. I enter it in this moving average template, and then you see that this template is able to do 2, 3, and 4. So we'll do all these 3, and I basically record the MSE for each of these Ks. For K equal 2, I have a 5,057 basically MSE, which is the lowest among these 3 different Ks. Okay, and then after that, I will do a single exponential smoothing. Okay, again, like what we saw, I will do that, and I will continue it for all different values of alpha. Okay, so here is my data again from 204 to 500. I will plug in 0.1 and get the MSE and continue this all the way for example, 0.9 and 1. And I see that, for example, here my lowest MSE is at 0.7. Again, comparing these two, I still see that my moving average has a lower MSE. And then finally, the last method that I can use is the basically regression analysis. So I'm going to go ahead and use the regression analysis as well. So in regression analysis, this is again my data and the same technique that we use. These are the coefficients. So this is going to be my intercept, and this is my time period. So if I want to have a regression equation, it's going to be y equal to 234 plus 17 times 37 times x. So this is my regression equation. And important thing here is that this is the MSE. Okay, so MSE or MS residual for this model is 3,326, which is significantly lower than all other models. The MSE, the lowest MSE that I could find in moving average with a K of 2 was 5,000 something, and for single exponential smoothing with an alpha 0.7 was again 5,200 something. And here I have a 3,300 MSE, which is the lowest MSE. I can also go ahead and do the plot. So this is going to be the technique that I will use. I will use the regression equation 2b2, and this is going to be the regression. I will use regression analysis, and this is going to be the equation that I will use. You see that my R squared is not bad. See that it's almost 70% of the variability is being explained, which is okay. It shows that there are some other variables there that I need to look into. But again, as it is, it's not really bad. And I can use this to predict the volume for the next time periods. And I cannot go that far because I'm not going to be very sure that the shape of this line will stay the same. And again, accordingly, I can manage to hire more people or put more people on overtime and so on and so forth. So this was an example of a micro case that uses forecasting in action and how you can compare these different methods. When we are doing all this in reality, the whole point is to have a dashboard that compares all these different models. Okay, so you can have basically your data input, and you see all the different results and be able to compare them together and find out which model is the best model, and so on and so forth. That's the key point here. And having different measures of error and being careful about the R-squared if you're using a regression analysis, for example. This concludes our works here in chapter 9. On Saturday morning, when we meet on campus, we will go over inventory management chapter, which is I can say, the most important chapter of all in your work. And we will take it from there, and we will discuss it. We will review some examples, and also the analytical parts, and we will watch a couple of videos. And next week, after that, we will have our assignment solved again 1 week from now on Tuesday. If you have any questions or you need any assistance, please stay on the call. I will be able to answer them. Otherwise, I hope you have a great rest of your night, and I will see you on Saturday, 8 a.m. on campus.
Have a good night.
Thank you.
Likewise. Thank you very much.
Thank you.